I made a shocking discovery today when I was hanging out over at MEUK's Discord server.
Are we gonna keep on fighting? Are we gonna keep on dividing?
Do you
Are
know
we gonna
what
keep on
word
fighting?
salad
Are we gonna keep on dividing? Well, are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well,
Sound level.
Would it not be horizontal all the way along?
No, I mean, I would call the whole line, like the whole infinite straight line, horizontal, but it's only horizontal, like if you look at it from this single point.
This is imagined, isn't it? This isn't. You're not doing this from any practical experience, or
Well,
any
it is-
actual geometric experience, or any logical thinking.
Well, it is a thought experiment that I can admit. So notions often were being created in simplest possible case, but then mathematicians found a way of cleverly generalizing that, so the same notion is applicable to basically more cases, and that's also the case with perpendicularity.
Okay, so go on then. Give us the mathematician that said that Euclid's wasn't quite right, and we're just gonna tweak this.
No,
what a perpendicular actually means.
It's not that Euclid
because
wasn't
the
right.
notion of it wasn't right. Well, what the hell did you just say?
It's not that he wasn't right. I didn't say that Euclid wasn't right. It's that you can extend it. You can modify the definition of perpendicularity maybe not modify, but extend it in a way that you can use the word perpendicular, referring not only to straight lines but also to arbitrary curves.
Do you know what word salad is?
We have a guest.
Oh,
I'm not entirely sure how to say their name, so
Yeah.
I won't attempt it.
A Bevlam?
That's me. Hi.
Hey.
hey, welcome.
Sorry,
Thanks. Yeah,
I didn't know you were here. I would have shut up a little bit earlier.
How do we say your name then?
To be honest, I'm not sure. Ebvalaim, let's say.
Ebvelheim.
Ebveline.
Okay.
Ebveline. Okay.
The name, I have an easier to pronounce channel name on YouTube, but yeah, I guess it doesn't matter either.
Can I call you Hey You?
Oh, well, your science something, are you?
Yeah, that's true. Yeah, I think you were the one who invited me to this Discord. Yeah.
Yeah, sweet. Oh, from from Mr. Sensibles. Is it? Is that what he's called, Mr. Sensible?
Speak truth. That one.
Oh, right. Speak
Oh,
Yeah.
truth. Nice. So that was the one where I was asking him if he wanted to have a chat about level being horizontal.
Yeah, that was the one.
Okay, and you disagreed.
Kinda. Yeah.
Okay, so can I ask that if you don't think it's horizontal, or you disagree that me saying level is horizontal? Well, first of all, because I said that, are you of the opinion that level being horizontal means flat Earth?
Yeah, that's a hard question. I guess it depends what exactly you mean by level and horizontal.
Well, I mean, they're both the same thing. Like when you get a tool that is a level, that establishes a horizontal line or plane of reference, and that is perpendicular to vertical.
Okay, yep. So that's what I would call horizontal. Yeah.
Yeah, but you would say that level isn't horizontal.
It depends in what context you use the word level, but in most contexts, I guess, like for example, sea level, I would say that, no, it's not the same as horizontal.
Okay, so in that case then, would you say that anybody that says level is horizontal, that means flat Earth?
If by level you mean something like the sea level, for example, then
Just the word level. I mean, yeah.
So that would kind of imply the flat Earth, I'd say, yeah.
Okay. So, if you don't agree with level being horizontal, can you tell us what you think it is then?
Okay, so, yep. So let's stick to the thing that you defined as basically a plane or a direction perpendicular to vertical. So let's call it horizontal.
Yep.
Let's stay with this one. And for level, let's say it's basically the surface that, for example, I don't know. So the way I defined it in the comment where we discussed it was a surface, an equipotential surface, for example, or a surface that is everywhere perpendicular to vertical. So not necessarily at a single point, but at every point, right? So that's basically what I wrote there.
But wouldn't that be everywhere perpendicular to vertical would be horizontal everywhere?
Well, not necessarily. For
Well, that's
example,
what
if
perpendicular to vertical is, isn't it?
Well, for example, okay, so if right now, let's say I'm not saying that the Earth is spherical, even though that's basically what I believe, what I think I know, right? Anyway,
Okay.
if the Earth is spherical, then vertical at every point is basically the radial direction, so the direction outwards from the center of the Earth, right?
Okay, so you're assuming that vertical is an extension of a radius.
Yeah.
Okay.
In-
I'm just
in
trying
case
to
of a-
keep this geometrically talking, then people can
Mhm.
understand.
Okay. So in this case, if we have a spherical Earth and the vertical direction is radial, right? So extending from the center outwards, then the horizontal plane or the horizontal direction is when you are standing at some point on the Earth, and you get this plane that is perpendicular to the vertical at this point. But if you take the vertical direction at any other point, it won't be perpendicular to this plane anymore, right? You will get a sort of triangle if you try to draw that.
Well,
So
yeah, I
So
think
this
are
way,
you getting
horizontal
mixed
at
up between geometry and if your vertical is an extension of a radius, then would that make the horizontal a tangent?
for example, yeah. But basically, you can have horizontal at different altitudes, right? So it's not necessarily tangent to the surface, but it might be somewhere above the surface or below the surface.
Okay, so it
But,
would be a tangent to somewhere above the surface, some arbitrary
For
point.
example, yeah. Yeah, for example.
Okay, so when you say horizontal, then at a point, how big would you imagine that point is? Because I do imagine that because you say it's perpendicular, that must mean it's a line, right? It's
A line or a plane, yeah. If we think.
yeah. So it
three-dimensionally,
has
then-
a length, right? And the length of that line or whatever would be the extreme points would be a point. Right, so the horizontal, where would you imagine that horizontal being horizontal, and how long would that horizontal line that you imagine that is a point, where would that come?
I'm not sure I understand the question.
Right, well, we're talking geometrically, right?
Okay.
And you've said that a vertical is an extension of a radius past the circumference of the circle.
Yeah, basically a line, yeah, I'm not sure what it's called in English.
It's just an extension of a
line.
radius, right?
Yeah.
Everybody knows what a radius is, and an extension is what happens on the other side of the circumference of the circle.
Yep.
Well, you're saying that horizontal is perpendicular to that line at the point at somewhere along that line.
Yep.
You are going to
Well,
make it
horizontal-
perpendicular.
horizontal at that point, right? Because that's the whole point of what
Well,
I'm
that's
saying.
what I'm
that
saying. Like you
horizontal-
said, horizontal at a point. Now, how long is the horizontal? Because you say it's perpendicular. Well, a perpendicular is a straight line in a relation to another straight line. I can get you the proper definition if you want. But
Yeah, no
you
need.
do understand it's two straight lines. It's a relationship of one line to another line.
Right.
Right. Now, I'm using Euclidean geometry terms here because that's just the way I express things, right? So if at any point you disagree because you're using a different geometry, you let me know.
No,
Right.
it sounds okay right now.
Okay. So if a perpendicular is a relationship of a straight line to another, then the vertical has a perpendicular that's called horizontal. Now, within the postulates of Euclidean geometry, a terminated straight line can be extended indefinitely in a straight line. So that part that you say is horizontal at a point, how do you imagine that horizontal to be at that point? Because the straight line would it not be horizontal all the way along?
No, I mean, I would call the whole line, like the whole infinite straight line, horizontal, but it's only horizontal, like if you look at it from this single point.
Okay.
So basically, if you are standing at this point on the Earth's surface, then this line that you can define perpendicular to vertical is your horizontal direction at this single point on the Earth. So if somebody else is standing on a different point on the Earth, then they will have their own horizontal line or plane, right, which is not parallel to your horizontal line or plane.
What makes you say that?
What makes me say what?
Well, forgive me if I'm wrong, but did you just sort of imply that horizontal lines intersect?
Kind of, yeah. In two different, if you take two horizontal lines on two different points on the Earth, then yes, they either intersect, or if we look in 3 dimensions, they might not intersect at all if they are. Again, I'm missing a word.
Parallel.
But not necessarily parallel. Like
Well,
they might
if
not
they
be,
don't intersect ever, then they must be parallel.
not in 3 dimensions, right? Because you can have two lines that are not parallel, but they are, let's say, shifted in the 3rd dimension, right? So they won't intersect, but they won't parallel
No,
either.
a parallel line is in 3 dimensions, right? Not only in 2.
Yeah, that's true. But you can have, but in 3 dimensions, you can have lines that are not parallel and they are still not in.
But yeah, but the definition of a parallel line is if extended, they will never touch.
Yep.
Well, you said they never touch, and I said like a parallel line, and you sort of disagreed.
Yeah, because I didn't mean necessarily parallel lines. Because, but okay, let's just stay in 2 dimensions because it will be easier. Because I'm missing words to describe what I want to say.
Okay, well, yeah,
Sorry, not
there's
an
no
native
need to
speaker.
go into 3-dimensional geometry, is the solid geometry.
Yeah, it's enough to just think in 2 dimensions to see the problem. So then, if we're thinking 2-dimensionally and it's across the Earth, which basically let's just assume now is spherical, so we get a great circle, right? And we take 2 observers that are standing in different
Sorry,
points.
no, wait a
on
minute. You
this
said
great
keeping
circle.
it 2-dimensional, right?
Mm-hmm.
Well, how can you stand somewhere with you? That's not 2-dimensional. If you're standing on it, then it's not 2-dimensional, is it? Because you're a 3-dimensional being.
Okay, yeah. So the
So do you
observer
want?
is.
Or we want to do geometry on 2-dimensional to express what we're talking about, or do you want to try and imagine 3-dimensional? Because that's very different, right? Although the circumference of a circle, right, is a curved surface, right, at all points. I mean, that's defined within Euclidean geometry. how to make a circle. And also within the postulates of Euclidean geometry, like I said before, you can extend a line indefinitely. So with you having a vertical and a horizontal being perpendicular, but then having your horizontals sort of intersect with each other, would that mean that, let's imagine two verticals, right? And each of these verticals have a horizontal with them, right? Now, they are perpendicular. The horizontal and vertical are perpendicular. So now, when you extend your horizontal, because you can extend a line indefinitely, would that horizontal line intersect the other vertical line?
It depends. It depends on if we're still on a globe Earth. Then it depends on how exactly you are. What is the exact distance between those two verticals?
But they can be
Between the
extended
points
because we're dealing with just a circular. We've drawn a circle, right?
Yeah,
and
but the
we've
point is-
extended two lines past the circumference, and then we're extending them out because we can extend them out indefinitely. Now, we're going to make the perpendiculars to these so-called verticals, right? Now, one of them, horizontal, would it intersect the other vertical or so-called vertical that you're going to have there and call vertical?
Yep. As
Now-
long as the two verticals aren't perpendicular to each other, then yes. Because if the verticals are perpendicular to each other, then the horizontal perpendicular to one of the verticals will be parallel to another vertical, right?
Right, so therefore, in that case, then, the rules of geometry would still apply, and we wouldn't be breaking any rules if we were to keep all verticals and all horizontals as defined perpendicular. Right, now, could you do that on your model?
What do you mean by do that?
Well, like I say, you quite conveniently shifted over to a different model. So we'll go back to the other one. We've got a circle, and we've extended two lines past the circumference. Right?
All right.
And then we're going to make a perpendicular on each of those lines. Right?
Yes.
And then we're going to extend all of the lines for as long as we can.
All right.
Right, now, when one of the lines that's a perpendicular, the one that you imagine is a horizontal, when you extend that, would it hit the other one, the other vertical that you're going to call, the other extension to a radius?
Yeah, I understand that.
Would it be
so-
perpendicular to that line?
No, usually not. Yes, if the two verticals aren't the same vertical, then
So in that case, then, you would have a horizontal that isn't perpendicular to vertical, wouldn't you?
Yep. Because in that case,
But
horizontal.
have you
is
ever
up.
heard of that? Have you ever heard of a vertical and a horizontal not being perpendicular?
But now you're kind of well. That is a bit of an equivocation because that's the point. The horizontal and vertical are only notions that have sense locally, so only at
But
a single point.
they are defined
horiz-
as being perpendicular, though, right?
Okay, but if they are defined at the same point, but now you're comparing horizontal that is defined at point A and the vertical that is defined at point B, and they don't really have to be
No, I think
perpendicular.
you're just
Only-
adding that in. You've
Not really.
you've added that in. A perpendicular defined at a different point doesn't have to be
But-
perpendicular.
Yeah, but that is
that's-
kind of
I've
a more
never
general
heard.
way of defining it, right?
Well, no, that's the geometrical way of talking about it. I mean, you can't get more well-defined than geometry. And a vertical and a horizontal being defined as perpendicular, I mean, that's a very definite position. And that's a very definite thing that's used in in practical real life things. Surveyors use it, builders
but
use it,
then-
architects use it.
Yep, but then any builder also basically, if they want to get the horizontal or the vertical direction, they either use a level or they use a plumb bob,
Yeah,
and
yeah.
they always do it at some point, right? So if a builder takes a plumb bob at point A and the builder takes a plumb bob and uses it at point B, then they have two verticals. They have a vertical at point A and a vertical at point B.
Yeah, yeah.
And now-
you have to. You can't transfer a vertical by distance, Mark. I mean that'd be silly, wouldn't it?
What do you mean?
Well, like in order to have a plumb, you have to have it at the position you require it, right?
Oh,
I mean
yeah.
that's what makes it plumb, and the horizontal plane that is established by a completely separate tool, right? A level. That's a horizontal plane. That horizontal plane is defined by the vertical and it being perpendicular to the vertical. Because the vertical is just a line, isn't it? It's the horizontal plane that is makes it a plane. The fact that it is a line and you can turn that horizontal through 360 degrees. I mean that is effectively how an auto level tool works, isn't it? You establish the horizontal, and it's a horizontal line of sight, and it looks out over a certain way, and you can turn that through 360 degrees. Now that's one horizontal, isn't it, all the way around? It's not just at that point where the
That's my point. That is a horizontal at that point where you're making the observation or basically the measurement of the horizontal.
yeah, but
So
you're not
basically-
making the measurement though. You're making the measurement away from that place.
Okay. Yeah,
That's
maybe I
just
used
where the optics
the
are.
wrong word, yeah. But basically what you're making is you're basically defining a horizontal plane at that point, at the point where you're standing with your tool. So
Yeah.
if you have two people, one standing at point A and a person standing at point B, and they both use and they both have the tool, right? Their own tools, and the person at point A defines their horizontal using their tool, and the person at point B defines their horizontal using their tool,
Yeah.
then, well, a priori we can't say that those horizontal will be parallel. I mean, they would be if you were right, but they won't be if the Earth is spherical.
Okay. So, do you know? Have you ever seen a water level? The tool,
Yeah, you mean, yeah.
like a big, massive hose pipe.
I'm not sure actually.
Well, let's.
Yeah, I'll drop it in debate discussion, that animation, Bev, just so
Okay.
that he's not confused.
Yeah, all you've got to do is imagine a big tube. Like imagine, you know what a hose pipe is?
Yeah, I think so. Yeah.
Right. Okay. Well, how big can you imagine a hose pipe to be? How long?
Oh, I don't know. Arbitrarily long, I'd say.
Okay. So let's say 50 meters. Let's say 100 meters.
Okay.
Right. That's you can have that, and you fill it up with water, and at either end, the water will equalize, and it will show the same level.
Okay. Yep.
Yep. Now, would you? I would say that is level, being a horizontal plane all the way in between those levels of water at each end of the tube, because that is effectively like one of the most basic levels. And that is a tool for establishing a horizontal plane of reference.
Okay.
You give us
I
that,
think
would
I
you?
even referred to that in my comment where under Seek Truth, Speak Truths post.
Yeah.
So I was referring to an experiment that someone on YouTube did, and well, it takes some resources, but you could actually repeat that and try it yourself, I guess. So basically, you take something like this water level. So you have a hose pipe that is long,
Yep.
but maybe not 100 meters, but even longer, like I don't know, half a kilometer or something like that.
About a mile.
basic-
How about that? We'll do a
Yeah,
mile.
let's say might be a mile.
Yep.
Maybe a mile. But then you not only take measurements of the you don't only take a look at the water level at both ends, but
Yep.
also in the middle. So you basically
We'll-
connect
we-
another pipe
we'll
in the
put
middle,
a
so
tap
that
in the middle. Yeah.
yeah,
Okay. So
so
we've
that you
got three.
basically have
Yeah.
3 vertical pipes connected by a hose, right?
Well,
and
just
now
one
you
one
feel-
hose from one end to the other, and we'll put a T junction right
Yeah,
in the middle,
exactly.
and have a I don't know 3 or 4 foot length of hose from there.
Yeah,
Right. Okay.
something like that, for example. Yeah.
What about
So then
right? Can you imagine now, because you've got that, and just to check that because a water level would establish the level between the two, can we make one that's half a mile long, and tape it to one end, and then have it go all the way into the centre, and also fill that one up? But it's a separate one, but it's used to check. Right, the end and the centre, yeah, because you want to measure the centre, don't you?
Yeah, kind
So
of.
we'll use another water level to help us check that centre mark as well, right? And then carry on with how were you going to check?
No, what I was going to say is if you have those 3 connected with a single hose, so basically you have one big what's it called, like connected vessel, I think, or something like that.
Yeah, one body of water. Yeah.
Yeah, so you have one body of water when you can see the water level at 3 different points, right? And let's say that the point A is basically where you're standing, point B is half a mile from you, and point C is a mile from you, right? So you have this giant body of water
Okay.
with 3 points where you can see the level.
Yeah.
Can I
So
just get a
that's some-
question? Can I just clarify something? Right, you've got the same body of water.
Let me.
Is it the same water surface in all 3 of the upright vials on your water level? You have the
So
same
what-
body of water running through the hose pipe, and you have the 3 vials. So the
yeah.
surface of the water in each vial is the same water surface.
Yeah, that's kind of the idea.
So it is one continuous surface of water throughout the length of this water level,
Oh.
yeah? The same
Well-
body, same surface.
Well, it's not necessarily continuous, right? Because the point is that
Of course it is.
well,
It's the same body of water, and one body of water only has one surface of water.
okay, if depends on what you mean by that, but yeah, basically that's the point is that those 3 those 3 vials, right, when you fill them up with water, the idea is that since they are connected, the waters should be on the same level in all of them, right?
Yeah, giving you
Yeah.
the same
I've got.
surface level
Can
of
you
water.
see my camera?
Not yet, but let me see. No, I don't think I can see it.
It's on Discord. I don't know what.
Oh wait. Wait, it tells me that I think it tells me that you're. Yeah, Discord tells me that you're streaming video, but I can't see it.
If you click on Bev's name and then double tap the image of his camera, can you see Bev's name in the list of people that are in the server? Second-
Yeah, I can.
Second one from the bottom. So tap on that and then
Try.
double click the image that's presented to you, and then it will give you full screen.
This- Because I'm using Discord via the browser, not the desktop app, so I'm not sure if that doesn't cause problems.
No.
But I think I should be able to see the camera, but for some reason I can't seem to.
Sorry, Redmond, I missed that.
Might be able. Can we get him a screenshot?
Yeah, I can give you. I can put a screenshot in the debate discussion if you want.
Okay. That will help.
You sort the mic out.
So basically, what Bev has got. Did you have a look at that animation that I put in the debate discussion?
I
That's a
haven't seen the
no.
animation yet, but
Yeah, well, you kind of understand. It only explains the principle of a water level, but you kind of understand that. So, right. So that screenshot is going in there now.
okay, yeah, I can see it.
Okay. So that's your water level. 1 mile.
Kinda. Mm-hmm.
Okay. And then the halfway point is the obviously half mile. Right, and then so the one in the middle.
Mhm.
What were you gonna say about that?
Yeah, exactly. So what I was gonna say is, since we have one body of water, they should be filled to the same altitude, right? To the same height.
Yep, to the same level. Because
same.
it's a water level. It's a tool.
Mm-hmm. Exactly. So the point is that somebody actually did that. Somebody did that experiment, and they used such a long water level.
Okay.
And then they looked. Then they looked from the point where one end of the level was,
Okay.
and they basically looked from the level, from the water level at one end towards the water level on the other end, right? So that basically in the image they were at the same level. And what they
Excuse me.
found.
Excuse me, could I ask you how long the water level was?
I don't remember exactly. That might have been somewhere around 1 mile, I think. I can try googling for that, and maybe I can find the original video.
Yeah. Okay.
That's good.
Yeah. I think we know which one it is.
Is it the gypsies with the transit van?
I
Is
think
it that
so.
one? Oh, right. Okay.
Okay. So we've got a guy there, and he's looking. Right.
Mm-hmm.
What is he seeing?
Yeah, so basically what he was seeing was that the water level in the middle one
Yeah.
was slightly higher than the first
Okay.
and the second. Third
Okay.
one.
So the this one, the first one, and the one at the very end. Yeah. Would you call them two horizontal?
And that depends.
Okay.
Horizontal at which point? Because
Well, that's what I was asking you earlier. What?
well, the line that would be going through the first and the last one,
Yeah.
so through both ends,
Yeah.
wouldn't be horizontal at either of the ends. It would be horizontal somewhere in the middle, but it wouldn't be horizontal at either
Okay.
of the ends.
Well, okay. Let's draw a straight line from one end, from A, all the way to B. Right. It's just a straight line that cuts through the level of the water at each end.
Okay.
Okay. Now, in the middle, the half mile point, you say that is where we have a level of water, right? But you said that video that you watched, it's higher. Do you have any numbers? Did they tell you how much higher it was, or what you'd expect it to be?
I don't remember. I would expect it to be really small. I don't know, a few centimeters maybe, so like an inch, let's say. But that's just a
1
random
inch.
number right now.
Okay,
I would have to calculate it. But the order of magnitude would.
I'll write it on here. 1 inch. Right? This the water level.
It wouldn't be
in here.
precisely 1 inch, but I mean this order of magnitude.
But so we'll fill that up. Now, we're going to draw a line from A to B. A to B, as far as we can go. Now that point in the centre, that's you imagine as being 1 inch higher than that line. If we were to drop a vertical there, right, a plumb bob, if we were to drop a plumb bob here, straight down, would the horizontal that one in the middle make, that there would be a horizontal, right? A perpendicular.
I got a bit confused because I still can see your videos, and I imagine you are drawing something on this, but I can see it. Let me try to figure out why I can't see you.
Okay, well,
Maybe it will be easier.
at the centre, we've drawn a line, and then at the centre, you're going to draw a perpendicular to a vertical. But so I suppose you would call that horizontal, right?
Wait, give me just a moment. I have an idea because I might be able to see your video in a while.
Okay.
That will be easier.
I'm just looking for that video of that water level test that you were talking about. Was it on Seek Truth, Speak Truth's channel?
No, I think he was just
I don't
talking
think
about
so.
it. I don't think he posted it. If you want that, you'll have to look Metabunk.
It was a Metabunk one.
Yeah,
Is it?
do you look up water level or something? Because I think somebody, Mick West, starts talking about Slice Barcane, you know, the failed one that he did, and he wrecked it, and it was about the campaign about how much money he was going to get. So Slice Barcanes, I think, was meant to be a replication of this one, but just worse and failed. He got a camera out of it, though, and he says 16 100-metre water levels in his basement. So he's sat on all of the tubing he needs to do this. Right, so
Still can't get the video to work, and I have no idea why.
we've got I've drawn a line from A to B on this
Okay.
board now.
Hmm?
Right, and then you say that the one in the middle is 1 inch higher. Right?
Well, one inch, about 1 inch.
You said
higher
about
than
1
the
inch,
line.
yeah, because you'd not done any calculations
Yeah.
or anything.
But just to make sure, A is one end, B is the middle, and C is the other end.
Oh, I
right?
can
Or-
change it for you if you want, yeah. A, just to make it, and that would be B there. Right, so you've got A, B in the middle, and C at the far end. So AC,
Okay.
1 mile, AB, out there,
Okay.
Right, like, it doesn't make sense that it would be higher in the
half mile. Hey,
So yeah, that
don't
video that
don't interrupt him. He's in his flow. Right, so it's there at 1 inch and it's higher, and we've just drawn a line in between A and C.
Okay.
It passes through B, right?
Mhm.
Okay, so if we was to drop a plumb line, plumb bob, right in the middle,
Mhm.
where it's you say it's 1 inch higher,
Mhm.
not calculated, just imagined.
Okay.
Would
yep.
that horizontal line, because you would get a perpendicular to that plumb bob in the centre.
Yeah, so it
Yeah.
should be perpendicular there. Yeah.
Okay, that perpendicular that you would call horizontal, would that be parallel to the line AC that you've said isn't horizontal?
Yeah, it would be because
Okay.
line AC is horizontal at point B. Well, as long as point B is exactly in the middle between A and C.
Okay, so that
So-
would rely on point B being directly in the centre of A and C.
Yeah.
Okay, now that would make them both horizontal then, wouldn't it?
Both, you mean, which is one and which is the
Well,
other?
the line AC is horizontal if it's parallel to the line at B that's perpendicular to the vertical.
Yeah. It's horizontal at B.
Yeah.
It's not horizontal at A, and it's not horizontal at C.
But the line from A to C is a horizontal line because that's parallel to the perpendicular at the
Yes,
center point.
But only at B. It's not horizontal at A, and it's not horizontal at C.
But the
And
line
not at
from
any other point.
from A to C is parallel to the perpendicular to the plumb bob right at the center.
Yes.
Okay. Right, now, if I was to move the plumb line and drop it halfway in the middle, do you reckon that would be... because if we could draw a line from A to B or A to C, and they're parallel, would that line be parallel? Because we put another tube in, didn't we? We put another tube in just to check this, but completely separate one, and filled it up to the same level.
But wait, where is the other tube? I think I got lost a bit.
Okay.
It doesn't help that I can see the video. It would be
Somebody
much
drop
easier
him
if I...
And see whether he's happy with that. I've
Maybe I
had
could
to, I've
just
had
take
to drop that
5
one
minutes
that you had a 1 inch in the middle to bring it right. Otherwise, these two bits wouldn't. In fact, we'll fill that
Hang
one.
on, you can't see its Bev's screen still, no?
No, I can't.
No. Do you want
Unfortunately.
me to do a screenshot again and
Yeah, wait a minute.
So
let
you
me
can
just,
see.
If you could, that
fill
would be
this
very
up.
helpful. Yeah.
yeah, move your fat head, Bev.
Wait a minute. I'm just doing a red.
Wait a
one 'cause-
minute. Alright.
Are you on the app that you can't see?
You know what he means by running the water level inside the existing water level, don't you?
I think so. Yeah.
So you've got your 3 vials, A, B, and C. You run a half distance water level. Mind your egg, Bev.
Here you go.
A half distance water level from A, other from B to C. So you are testing, or not testing, you're confirming the level of the water with a water level, your water level.
Unfortunately, you broke up there a bit, so I got like 50% of what you said.
You'll see, I'm just about to send you this screenshot. So
Okay.
not send you, but post it. So you have a water level inside your water level. Can you see that?
Okay.
See the red one?
I
So,
see.
so you have A, B, and C is your 3, let's say 3-point water level, yeah, because there's 3 points of reference on it. So your 2-point water level goes from A to B in the center. So this is an independent water level. This is nothing to do with your original water level.
Okay.
Yeah, and then you do the same again from B to C. So you have your original 3-point water level, and then inside that you have a water level, or 2 water levels, each of half distance from your center point to your end point.
Okay.
And you would agree that they would have to line up, wouldn't they?
Yeah.
Because obviously,
So as long as you fill them to the correct level, then yeah, they would have to line up with A and B and with B and C. Yeah.
okay. Right. So, like I say, I had to take that inch difference that you had in the center out of it because it wouldn't work. We wouldn't be able to draw a line like that because they're horizontal has to be same, doesn't it? If it's like if it's a tool, I mean, you put a bit in the middle. Now, if it's a tool that establishes a horizontal and water levels don't come with a tap in the middle, they just come like as a tube, and you know, like you can establish the same level from one end to the other. It's a horizontal plane of reference.
Yeah, that's the point. It's approximately horizontal as long as the two ends of the level are close together. If they are farther apart, it drifts away from horizontal more and more.
If it's not
the more
horizontal,
distant
we did do this at the beginning. If it's not horizontal, what is it? Would that mean it's on a slope?
That's what I would call level. So basically, they would line up along a circle.
Sorry?
I wouldn't call it a slope exactly, because basically they would be on the same level, except if you drew a line through the two vials, let's call them.
A straight line.
It wouldn't be a horizontal line. Yeah, it wouldn't be a horizontal line. It wouldn't be a horizontal at either end.
But it is a tool for establishing a horizontal, right?
Yeah.
You can move one end of it to anywhere you want. And
yeah, that's true.
The line established would be horizontal, right?
Maybe let me try to make a quick drawing to better explain what I mean.
But we are drawing straight lines here, right? In between one point and another point, we draw a straight line.
That's true.
Okay. So if we're drawing a straight line and it's not horizontal, it must be a slope.
Well, yeah, the straight line would be, yeah.
Okay. So when you say from A to C, where is it not horizontal? That line that's established.
The line from A to C?
Yeah.
So it's not horizontal anywhere apart from B.
But it's a straight at B it is a straight line.
Yes. It's a straight line.
And you've said
everywhere.
that straight line at B that you do imagine is horizontal is parallel to the line that you established between A and C.
Well, yes.
Well, would that not make it horizontal all the way along it? Because it's a line that's parallel to horizontal.
The line that you put, the line that you can, the line through A and B would not be parallel to the line through A and C, for example, and not parallel to the line through B and C.
I don't understand how you can do that. Can you show us? I mean, you are using Euclidean geometry, aren't you?
Yes, I am.
So a straight line doesn't curve just because it gets a bit bigger. Right,
yeah,
that stays a straight line.
No, but see, that's basically because of the fact it's basically because of this observation in this video that this middle one, if you take the water level in the middle one would appear to be above the line that connects A and C. Yes, which means that if you connect A
when
and
does
B,
when does water raise it up to find its level? Does that how can you say that's what water does then in a water level? How does it raise up and be level?
It doesn't raise up. The problem is it doesn't raise up. It's above the line because basically the water surface aligns itself with an equipotential surface, and the equipotential surface on the Earth is a sphere basically.
But
so it's a bit.
You've only got two ends of a water level.
Yep.
You've just added a center point in there. I mean, that you wanted to add that in, I presume, because you wanted to say that it was higher than the other two ends.
And it is the same surface of water.
Yeah,
we've established that water. Water only has one surface.
Yes.
Yeah. So, I think.
But that's the point. What we observe in reality, this one surface turns out to be higher in the middle point than in the end points, which basically means.
No. That's not how water
Can I
level
just
works,
check?
is it?
You say when we observe. Have you ever worked with any tools that establish a level?
I did, yes. Well, not at this scale, admittedly,
Okay.
but yeah.
Well, what was the biggest scale that you worked with a level?
Oh, a small one. I don't know, a few meters maybe.
A spirit level.
Yep.
Okay.
Not more than a few meters.
Okay, but that was definitely, it was a straight line, that spirit level. It wasn't bent, was it?
No, it
Okay.
wasn't.
So, can you imagine if you was to put that on something that was even longer but straighter? Can you think of anything? What's the longest, straightest thing in the universe that you can think of?
I'm not sure where you're going with
What
it.
was that thing that that dude was talking about?
LIGO, Bev.
LIGO.
That one.
LIGO. Have you ever heard of LIGO?
Oh, yeah. Yep.
Some
The
dude was
interferometer,
telling
yeah.
us that is the longest, straightest
Longest,
thing
straightest
in the universe. I think he said,
universe.
yeah, it was.
Yep. Yep.
So
I wouldn't-
if you were
I
to
wouldn't
put,
go as far, but yeah, on Earth probably.
okay, if you were to put that spirit level that you've used right on top of that straight thing, then that would extend the level of the spirit level, wouldn't it?
Not really.
Oh,
Well, at some points probably, at some points not necessarily.
okay. So that
Has to-
you know how a spirit level works with a little bubble in it,
Yes.
right?
yes.
Now, how big's that LIGO? Do you know?
A few kilometers. I'm not sure how
Okay.
many exactly, like 4 kilometers or something like that.
Oh, take it. So let's say there's a big, massive, long, straightest thing in the universe, and you've got your bubble level, and you can put it anywhere along that thing, right? And you know how a bubble level works. The bubble has to be in the
Yes.
middle. Where would that bubble level, in your imagination, as you're moving it, where would the bubble be in the middle?
Well, it depends on how exactly they constructed this tunnel, but I would imagine that probably in the middle of the tunnel.
Okay,
At the
so
ends, not necessarily.
So if it's the longest, straightest thing, so if you were to move it, it was level in the middle, and you were to move it to the other end. Where would you reckon the bubble would go? Which side?
Probably towards the middle, so towards the middle of the tunnel,
Okay.
because basically the tunnel. Yeah, it would help if I could draw. So if you give me 1 minute, I can draw how I imagine it.
So, can I just? You're saying it curves up at the end?
No.
No.
Yeah, we'll get
It
there in a
doesn't-
minute. We have to get our
The point
plumb
is,
bobs out.
the point is, it doesn't curve, but the Earth is curved, and so the verticals at the two ends
Yeah.
are basically a bit outwards, directed a bit outwards.
Outwards
So
where?
the idea is that
Outwards at
like
the top
outwards relative
or at
to
the
the
bottom?
tunnel.
Yeah, if we hang a plumb bob at each end, right, and
So at each end, it will probably be a bit oblique. So it would point like if you hang a plumb bob from the end of the tunnel, it would probably hang slightly towards the middle of the tunnel.
okay, so they would point. They'd be closer at the bottoms. The closer, the longer they
Yes,
got.
exactly.
Okay. Now imagine you've got this is the longest, straightest thing ever. Imagine you've got a ball, like a a 3-dimensional sphere,
Okay.
right? And you put one at each end. What would happen? Do you reckon?
Like a physical ball that can move in
Yeah,
the tunnel.
it can
right?
roll, obviously. Yeah,
Yeah.
and obviously
so-
the surface.
Yeah, so I would expect them both to roll towards the middle.
You'd have the balls rolling towards the middle,
Yeah, that's what I would expect.
and the plumb bobs also go in towards the centre. And when you put a bubble, a spirit level, to each end, the bubble would also go towards the middle.
That's what I would expect. Yes.
Have you been talking with Zanuck?
No, I don't know
No.
who that is.
Because he said that as well. But like to me, you've got a few different models there in one go. You know, you sound very
Why?
confused because if it's a straight line and you can put a obviously your level is a straight line and you can extend a spirit level by just getting a straight edge and putting the thing on it. I mean, that's why joiners have little tiny levels, because they normally have a big long straight piece of wood that they can use. Brickies are the ones that need the big long ones because they've got to go over little bricks, so it needs to even it out over the top of them. And a water level establishes it from all the way from one end to the other end. It doesn't really matter how far it is. It's the most accurate level over distance there is, right? So if it's a straight edge and you put a level on it, it's going to be level, right? If you put it in the middle, to the left, to the right, it doesn't really matter. Wherever you put that level on that straight thing, it will be level if it's the longest, straightest thing ever.
At a small scale, no, but at a large scale, it depends.
Okay, but
at the small scale, basically, the differences are too small to be perceptible with such a tool. So basically, if you have a really, really straight thing that has, I don't know, length of 1 meter, let's say, then it can't be horizontal at all points. If you for example try to make it horizontal using a water level or a bubble or a spirit level or whatever, then if it's perfectly straight, it will only be horizontal at a single point, and it will not be exactly horizontal at the ends, let's say, or for example, let's say you make it horizontal.
We did this before. You said it's not horizontal from one end to the other, but they're at the center point. If you drop a plumb bob and make a horizontal at that point in the center, that would be parallel to the one that I guess, can we call it a chord?
Yeah,
do you imagine it's a chord?
Okay.
Is that what you're doing?
But if you, for example, drop a plumb bob, let's say, okay, so we have this line, let's go back to our water level that is a mile long, right? So if you drop a plumb bob at B, it will be perpendicular to the line that goes from A to C. But if you drop a plumb bob at A, it won't be perpendicular to that line, nor
Why?
at C.
How can it not be perpendicular?
Because at that distance already, well,
it's like you've got a mile that there is a horizontal over a mile. That how can you imagine that you go to one end of that where you have a horizontal already established and drop a plumb bob to not find your horizontal is there already? Because it is. You've just done it. You've just said it's horizontal from A to C.
But only at B, because the plumb bob will be perpendicular to it at B, but it won't be anywhere else.
This is imagined, isn't it? This isn't. You're not doing this from any practical experience or any actual geometric experience or any logical thinking.
Well, it is a thought experiment that I can admit. But basically, if you had precise enough tools, like for example a theodolite or something, you would be able to measure this difference.
Yeah, a theodolite, or let's call an auto level, right, is a tool for establishing a horizontal.
Yep.
Right.
So if you use that, you would find that if you, for example, put a theodolite at A and aim it in the direction of B and C, and level it exactly so that you look perfectly horizontal, then you would find that B is a bit below horizontal and C is even more below horizontal.
Oh, so yeah. We've got Jesse. Have you heard of Jesse?
I think Jesse Kozlowski, yeah?
Yeah.
I've heard, yeah.
Yeah, what you just said then, that the water level drops away from the horizontal.
Yep.
Yeah. He said that. He said it's measurable. Right? Would you agree with that?
Yeah, with precise enough tools, yeah.
Okay, so the water level drops away from the horizontal. Can I get it? I'll get it and put it in debate discussion. So you're not like thinking I'm lying and he didn't actually ever say this.
Can I just get an aside, just
Yeah,
briefly?
go on while I'm
Bev?
finding this. I can make a brew if you want.
Can I just get from you, because I've dropped a link to that video that you were referring to. I dropped it in debate
Yeah, I
discussion.
think it's that one. That's true.
Is that the one that you were referring to? Yeah.
I'm pretty sure. I've only seen the miniature for now, but I'm pretty sure it's the one. Yeah.
Yeah, they got a white transit van and they drive along the road.
Yeah.
Yeah. Right. Okay.
So that shows it's higher in the middle.
Not really, because when you are looking from A to C,
So you
see
don't
that it
see
is
them
above this
looking
line.
from A to C. You just see them driving down.
I think you see.
No,
There
you
is
don't see
absolutely no measurement references
No?
at all in that video.
Okay, let me take a look at the video again, because maybe they just described what they did and didn't really show that.
They didn't show anything. The video is 4 minutes long and they show nothing apart from them driving along the road and having a look at some liquid.
Yeah,
that
they
is
don't describe
contained-
anything either.
Nothing.
There's no sound.
Nothing at all.
Okay,
Absolutely nothing.
all right. So let me just take a look because okay.
And our test is very much like that one, except it's much better.
I don't even know why he's got it on that Metabunk website, because it is an absolutely atrocious video.
Yeah. Can you remember when somebody said to us, "You'll have to watch out what I think it was Brian." He said, "You'll have to watch out what you're doing, right? Don't try and use them pressure lock hoses, because that's how they work with pressure. You need to have a pressure lock."
Yeah.
Wait.
Don't use them because they rely on the pressure of the water, and you won't have any if you're not pressurizing it.
Yeah, not a pressure. You can't have a pressurized system, right? Because it's just open, isn't it? It's a one body water thing open to the air.
Yeah,
let it equalize.
They do leak if they're not under pressure.
Yeah. So basically, I've looked at the video.
Yep.
And it's true that they don't show here what the method was about, but I recall, I don't know, reading somewhere maybe.
Yeah,
or
it's in
I
the
don't know.
comments.
But
They've done a bit of writing in the comments.
Probably.
Only a little
so the
tiny
idea
bit
was
of writing, right? Not...
Yeah. So the idea was that the yellow and black stripes, those parts that they were using to mark the level, they were aligned using a theodolite. So they were basically seeing through the theodolite, using it as a scope.
But the video
basically-
doesn't show any of that.
Yeah,
Yeah,
I
it
was
doesn't
gonna
show
say
it.
that.
That's true.
I mean, literally.
So yeah, so basically the video cannot be taken as proof, and I will grant you that.
Yeah, nice.
But
I'm
it
glad.
shows the method that you could use to check if
That you
got the
could
process.
use.
Well,
Okay.
we've got a test. So
Yep.
that's what we were explaining on the other board, right? But you give us what they showed. I mean, maybe why you were saying this thing, that you were showing that it was level from A to C, and then you had a lump up in the middle, which is what that showed, right? I mean, is that where you got the idea that there would be a hump in the middle?
Not really. That's what basically I would expect based on well, let's say knowledge about the world, if I can call
You mean
it
the
that.
model?
Yeah, let's say the model. Okay.
Just a minute, I've got to go to the door.
So yeah, basically based on the model, on the spherical Earth model, that's exactly what I would expect.
So there's no practical real world example of what you would expect to find on your model.
Well, that was supposed to be the practical example, but they didn't show the whole stuff. Let's say the whole thing. So they didn't really show that those 3 markers along the water level are
Yeah, you mean
aligned.
the video was supposed to be your practical real world example of what you would expect to see on your model?
Kind of, let's say, but well, that's more like an example of a method, right? So
I wouldn't even say it's that.
Sorry?
I wouldn't even say it's that. It's not an example of a method. They are not giving you any methodology at all in that video.
Well, yeah, that along with the description, right? But basically, the idea is that if you have some markers that you align using basically light, right? Because if you are looking through the scope, what you're using is de facto light. So if you have 3 markers aligned along a single straight line,
so it becomes an optical test.
Approximately, because of course also light doesn't exactly follow straight lines in the atmosphere, so that's another thing.
You've got a variance there. You are turning a physical practical test into an optical test, and we all know that the atmosphere plays around with optics.
Well, yeah. So if you want to be super hyper precise, you would have to do this in a vacuum, for example, which would make it a bit harder.
Why do you need to do a water level test in a vacuum? What would happen to the water in a vacuum?
No, not the water. The water shouldn't be in the vacuum because that's not a good idea. But the markers that you align, if you wanted to make sure that they are along a straight line, you would have to align them in a vacuum tube or something, so that you are sure that when you are looking through the tube, it's a straight line.
You just said earlier about using an auto level to form a horizontal.
Like theodolite.
Yeah.
Theodolite,
that's
auto level.
Yeah, well, that's approximate, right? Because theodolite also uses optics, right?
Yeah, but that's a different check, right? Innit? Can we not just stick to the water level and use the geometry to prove this?
Well, the point is, however many points you have on the water level,
yeah,
you can't be sure you are on the straight line until you have a straight line as reference, right?
Yeah, because the water level, right, can establish a horizontal plane. That's what the tool is.
Yeah, well, that's the point. That it works like that. Well, it works approximately on small distances, but
you can imagine that doing that when you think of a spirit level or an auto level or any other sort of level, but you really struggle at the point you come up against a water level, right? It's a different sort of tool. It works from one level and it changes that level to anywhere else at the other end of the hose pipe or whatever, the other end of the body of water. Here. It is equalized across the entire length of the body of water.
Well, yeah, but the point is here to use an independent method to check whether this
we can do that afterwards.
Level of water actually.
Yeah. But so when you imagine a water level at 1 mile long, right, and then because you're gonna have to give them you have to give them A and B. I don't particularly, because they're the same water level and they're on the same level, right? But you imagine they're on 2 different levels or 2 different horizontals. With one being higher than the other.
Let me put it differently. What I basically think about that is that all of the however many points you put on such a water level, be it 3 points or maybe 4 or 5 or however many you want.
Yeah.
So however many of those intermediate taps you have on the water level. So the water will be at the same level in all of them, this this line of those points marked by the water level in those different vials, let's say, won't necessarily be all on one single straight line, and actually they won't be.
Okay, well, I did this the other day.
So they won't form a straight line. They will be at the same level, like the same water level, right? But it won't be a straight line. So that's basically the point.
Okay. Can you see in debate discussion text channel?
Let me check. Okay. Okay, yeah, I can see.
So you've heard of logic, right?
Mm-hmm.
And you've heard of a logical statement
Yep.
with an antecedent consequent relationship, right?
Yep.
P and Q.
Mm-hmm.
So we've developed this because we found that logic is sort of, it's like maths, right? You can't deny it, especially if you're using deductive reasoning.
It's a branch of maths, yeah.
Yeah, okay. So if you're using deductive reasoning, you get a result, right? A definite result, one way or the other. So in this, take this on, right? If the Earth is a spherical object, this has been set up for a modus tollens, right? If the Earth is a spherical object, P, antecedent, then the surface of liquid water must curve, Q. Would you agree with that?
Yep, I can agree with that.
So that is P and Q have been checked, and Emma would be proud.
Mind your P's and Q's.
Yeah, so we've minded our P's and Q's. Now, I would give to you for a modus tollens that a water level is a tool for establishing a horizontal plane of reference.
Yeah, and
okay. So wait a minute, and underneath that, can you see that little drawing?
Yep.
Right. Well, all of the tubes of the water are connected. That's why they're all different colours. So the ones that are together are connected together, and they establish a level in between those tubes. Now, I would say to you that you could move any one of those particular tubes and position it anywhere else on that in that sequence, and it would stay the same level, thus establishing that is a horizontal line, and it is a shared horizontal line, as it would have to be, because from one end to the other, that's a horizontal that is set by that water level. Now, every little line in the middle would be a shared horizontal.
No, that is the problem, because no, it doesn't really follow, because they will be all along one.
It is a proposition, right?
Well, it is
within
but
Euclidean elements, right? It's not been falsified.
Well, the problem here is that, well, the experiment like the one from that video, which, well, maybe the video was not complete, but an experiment like that.
You call that an experiment?
Kinda, yeah. It well,
kind of
experiment.
Kind of experiment.
Yeah.
Well,
surely it either is or it isn't.
Yeah, you would call science or something.
Oh boy. It depends how you exactly define an experiment and what exactly do you expect. Basically, you can say that
you have to manipulate a variable, right, in order to make it an experiment.
Not necessarily. Well, that's
can you just look at something then?
Yeah, I'd say so.
Okay, well, basically, I can definitely look at each end of the water level. So, hey, if we want to call it an experiment, I'll go for that. If we can look at something, look at a tool that's due. Well, wow, would that make builders?
Experimentalists.
Yes, scientists. Anybody that holds a level and looks at it.
Basically,
I
would call an experiment basically every what should I say? how should I call it?
Observation.
Yeah, maybe an observation, but
So when I
I
look
was
at a
looking for a
clock,
better
am
word.
I doing a time experiment?
Nice.
Not necessarily. If
Look
you
at
are
it
looking
twice.
at the clock, if you are looking at the clock in order to compare what you see on the clock with the prediction of some theory, then I would already call that an experiment.
Okay, so we
If
want to
if your theory
compare a
predicts
water
that the-
level with something of a theory.
Yeah. So basically, a spherical Earth model predicts something about the water levels in this water level as a thing, right? And
Okay,
you
well-
can look at the water levels in this tool
Yeah.
to see if the reality matches the prediction.
Well,
And that I would already
it
call
is
an
a
experiment.
tool for establishing a horizontal line or plane of reference.
Yeah, as long as you are using it correctly, so over a small distance. Because if you are trying
I've
to
never
use this,
seen a distance maximum. Must be used within the. I don't think it's ever done that.
It does
Let
actually
me-
say in the definition of a water level that the more it is
Yeah, I'll
more
get you that.
accurate over distance.
Yeah.
So the further you
up until a
use
point.
No. It
Yeah.
doesn't say up until a point. It just
No, it
says it
doesn't.
is more accurate over distance.
Yeah. But
Yeah. Can
the
you
problem
show us
is-
where your definition of it is then, please? That gives us a maximum distance, because like. Some of us are actual working people. We've actually used these tools to establish horizontals. I mean, some people's
Okay.
jobs actually rely on this horizontal.
Okay,
Right?
but have you used it over 10 kilometers, let's say? Because
Used
you
what, a
usually
level over 10 kilometers. Why would you do
exactly.
that?
Yeah, exactly. So that's the point. If you
Okay.
tried to, then you would have some accuracy
What
problems
about
because if you
27 miles? That's the biggest level I've ever seen. Personally seen.
27 miles?
Yeah.
That's a big old level there.
Yeah. In a canal. A canal 27 miles long.
So have you seen the other end directly? So were you able to see both ends of the water
I've been
level
to both
over
ends of
27
it,
miles?
yes. I've been to spots in the middle as well.
Okay, but have you been able to see if all the points along the canal align on a straight line?
They're the same level, yeah. It's the same. It's the same
but-
body of water, yes.
Okay, but have you been able to check if it's actually a straight line?
It's not a straight line. It's a canal. It bends and goes all over the place. Just like imagine a big hose pipe, right? It doesn't have to be a straight line. It can be curved and fill it up with water, can't it? It doesn't
Yeah,
it
of
doesn't
course.
have to be a straight
No.
line to fill something up.
No,
with
but that's not what I
water.
mean. I mean, if all the points on the surface of the canal, if you were from one shore to another shore to the other shore, right? If you were to pick a few points on the surface of the canal between the two shores,
Yeah, the surface
would you
of
be able to
liquid
check
water.
that they, yeah, and
Right,
would you be
well-
able to check that they actually lie on a straight line?
A water level is any device utilizing the surface of liquid water to establish
but
a
the problem is-
horizontal plane of reference.
Perfect. But the problem is when you are standing at one side of the canal, you won't be able to see the other side of the canal. And in order to establish a line through both ends, you would have to be able to see both ends simultaneously.
You
And
don't
what's more,
need
you would
line
have
of
to be
sight.
looking.
Yeah, wait a minute, there's another bit here. You might be interested in this. The water level is lower tech than the laser level, but it can be more accurate over long distances, and this is the most important bit, and it works without a sight line. Yeah, so to use the tool that uses the surface of liquid water to establish a horizontal plane of reference, to use that
except-
tool, you do not need a sight line. It's one of its massive advantages. It's one of its best advantages, actually, because it
Yeah,
can be
on
used over
distances.
long distances, and you don't need a sight line. It still establishes a horizontal plane of reference, even if you can't see the other end of it. It's brilliant.
Not a horizontal plane, but but a common level. Yeah, I'd agree to that, but it's not a horizontal plane.
Oh, so it's the horizontal plane bit in the water level device that you disagree with.
Kind of. Well,
Okay.
basically.
So what is the horizontal then? You know,
No.
what does the tool actually do?
So what the water level actually does, it basically shows you a few points along an equipotential surface. So the equipotential, like basically on a spherical Earth, well, it's a few points on a sphere. Usually 2 points, because usually you have 2 ends on the water level, right? So both ends will lie at the same, let's say, altitude above sea level. And 2 points are always on a single line. But basically, the closer they are together, the more the line through those 2 points approximate a horizontal line. But the more distant you make them, the more you deviate from horizontal. But it's really small. It's
which
really small
geometry are you using here?
No, that's still Euclidean geometry.
It's
But
not.
the idea is-
You've got some sort of a length of a straight line, and then it deviates from a straight line. But you've got to imagine a sphere underneath it, and eventually, if you go short enough, it will actually follow. This straight line of yours will actually curve all the way round to join itself again, won't it?
This is independent of geometry. This is just physics now.
It's independent of geometry.
Oh, of course.
Physics using lines.
Yeah, it is.
Have we just gone from geometry to science in one step? And how are you
Kind of,
explaining this now then?
Well, the moment we introduce water, we kind of deviate from pure geometry, because water is not a geometrical entity.
The water is only there to establish the horizontal plane of reference.
The problem is the water doesn't really establish a horizontal plane. It
Can
does
you prove that?
approximately over low
Can
distances.
you prove that water doesn't establish this horizontal plane?
Yeah, one of the way of proving that is basically what they did on the video, which
No, the
I
video
admit,
doesn't prove anything.
I'm just gonna play this clip now from Jesse. It's not very long, right? You have a listen to it yourself and see if you agree.
I'm saying, personally, I believe the things that you teach your child, your autistic level. No, you teach your child application of that.
Tried measuring this? The level. You can measure this. Have you tried measuring this? The level surface drops away, drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared. I did not say that the level is not horizontal. Oh, yeah, it's measurable.
Okay. So Jesse says you can measure it, and the water level drops away from the horizontal.
from a horizontal established at your point of observation, yes.
But the tool is a tool for establishing a horizontal.
Approximately.
And you said the horizontal that the tool establishes is in the middle of where the 2 ends are.
Yes.
Right, so that is horizontal, but the horizontal that it drops away from is the horizontal that's set at the beginning of the point. But we've just said that that beginning point at point A and point all the way to point C was actually horizontal.
It's horizontal in the middle, yes. But you could have other methods of establishing horizontal at the point where you're actually making the observation.
Okay, so well,
if you establish...
If it's a horizontal in the middle, then where would the drop be measured from?
Yeah, that's the point, because...
So not A, the drop wouldn't be measured from the point you're at point A.
No, it would be measured from A, except you wouldn't be able to do that using a water level, because a water level wouldn't show you the horizontal direction at A. It would show you a horizontal direction at some other point.
A point in the middle of where the 2 ends are. But if it's a tool for establishing a horizontal plane of reference, what would be the point of it establishing a horizontal at a point that the 2 ends aren't even at? How can you explain that? In a working
most-
sense, imagine you're a working guy and you've got to establish a horizontal.
Yes.
Right.
The point is, in the most practical applications, this doesn't matter because it is good enough of an. It is good
How
enough
can you
of an
say that?
approximation.
How can you say that when it is a tool for establishing a level, but you cannot establish the level from the point that you're measuring at? The level is established somewhere away from where you are, according to you.
Yeah, that's my point. Because in most
but this
practical
is rubbish.
applications, it doesn't matter. It
No,
doesn't matter
because
in most
practical applications, you need the level, not an approximation of the level.
A half distance
But what you
in
get
between
is actually
the
an
total
approximation,
distance.
but the approximation is good enough that nobody cares. Really.
It's
Because
complete
it's-
rubbish. You are speaking now.
If it's within a fraction of a degree of the true horizontal, then it's good enough, basically. The problem is, well, the point is, if you, for example, were building LIGO, then it would matter, and I can guarantee you that they weren't using water levels in order to build LIGO.
So
They were.
which levels were they using then?
I have no idea.
Okay.
No, but you can guarantee that they weren't using water levels, but you have no idea what levels they were actually using.
Yeah, I can guarantee
well
that
done.
because I
done.
because I know that the water level wouldn't work for this application. Because
Can we
then
get him on the canal? With that might help you. Have you ever heard of the Ballers Canal?
Sorry, again.
Did you? The Ballers Canal. Have you ever heard of that? Did you see what we took Mr.
I'm not
Sensible
sure.
through it the other day?
No, I don't think I've heard of it.
Okay, brilliant. Let me see if I can find it for you. It's basically a canal, right? Are you? I know you say you're big on science. Are you big on geometry as well?
You could say that.
Okay, so let's imagine we've got a canal, and this canal is a triangular canal.
Okay.
I can't even remember where I put it. I think I might have put it in here. And it's 1 mile length. The sides are 1 mile. Each side, all three sides. So it's an equilateral triangle. Do you know the how many angles there would be in the middle there? I mean, obviously it's a triangle. But do you know exactly how many angles there would be? Or could you make a
So
guess?
I'm looking for 3.
Yeah. Well, we know there's 3 angles, right?
Yeah. Okay, so we've got a triangle.
Yeah. And so each of the angles at each of the 3, because it's an equilateral. Any idea how many there would be?
Yeah. Wait, but you were saying something about the size of the triangle, right?
Yeah, 1 mile.
Okay, yep. So approximately 60 degrees.
Approximately?
Yes.
Not exactly?
Not exactly. Well, depends on how you measure the angles.
In between 2 straight lines. It's the inclination of one straight line to another, right? In
Yeah,
measuring
but the
angle.
point is... Yeah, but now it will be hard for me to describe what I mean.
Okay, well,
Because,
I would say a triangle has 180 degrees, so an equilateral
On a
triangle
plane,
would have
yes.
60. No, I mean a triangle is 3 3 straight lines,
it is
right?
Yeah, if you take a triangle as 3 straight lines, then yes, 180 degrees.
And take the angle like as a definition of an angle, which is the inclination of one straight line or plane to another.
Okay.
Right, so in order to have an angle, you need 2 straight lines, and to have 3 of those angles, the minimum you could have is 3 straight lines and thus 3 angles. A particular shape called a triangle. And it has
Let me put
180 degrees, doesn't it? I mean,
Yes.
that's the very definition of a triangle.
Okay. Let me put it this way. If you define the angles in the triangle you mentioned as the angles between the lines from between the lines. Okay, so let's say the triangle is ABC, right? The vertices of the triangle are A, B, and C.
Yeah.
So if you just take straight lines from A to B and B to C and C to A, then if you measure angles between those straight lines, you will get 60 degrees each.
Okay. So if imagine you're sighting triangles and you're up on top of a mountain and you're looking at from A to B and B to C, that would be straight lines, right? And then that would then make that then a triangle, like in the true sense of a triangle, with 3 straight sides and 60 degrees.
Yeah.
Okay, right. Well, we've got a canal here, and it's a triangular canal, and we're in a boat and we are on the water at A, at point A, and we're going to go from A to B. Now, we're going to establish a horizontal at a horizontal plane.
Okay.
Now, we are then going to go to B on our little boat or canoe or whatever.
Okay.
Now, how much on your model would you drop away from that horizontal? Like Jesse Kozlowski said, the water level drops away from the horizontal at a rate of...
Yeah, so that would be about 8 inches, right?
Okay. So you've gone from A to B, and you've gone down from that horizontal plane 8 inches. Now we're going to...
from the horizontal plane, yes.
And then we're going to establish another horizontal plane at B. And we're going to go from B to C. And what would happen again? It's a mile again.
Yeah, again 8 inches down.
Okay, so from the original horizontal, we've established another horizontal, and then we've gone down another 8 inches, and then we're at C, and we're going to go back to A. And we're going to set another horizontal.
Yep.
And then we're going to go back to A. So, same again.
So same again. Yep. From horizontal at C, 8 inches down.
Okay, so we're back at A on the same water surface.
Yes.
But from the original horizontal that we've set at A when we started this, we've arrived back at the same horizontal. Yet we have dropped. What's that? 24. We're 24 inches lower in relation to the initial horizontal that we set.
You cannot really sum this because you are changing the reference plane along the way.
No.
So you
a
cannot
horizontal is the reference frame, right?
Yeah, that's the point. You have 3 different horizontal planes because horizontal at A is different from horizontal at B, and it's different from horizontal at C.
But that's not what horizontals do, is it?
Well, it is kind of on a sphere.
Oh wow. Would that be like Cartesian coordinates system?
Yeah, you could use a Cartesian coordinate system.
So that would make X and Y on the horizontal plane.
On the horizontal plane at which point? Because
exactly,
you have 3 different planes there.
Yeah, you've got a Z, haven't you? You've got your Z's your vertical, right? And then your X and X and your Y. Well, your Z would be vertical, right? Is that not what your Z axis is within your Cartesian coordinate system?
Well, here, if we are on a sphere, you won't be able to define Cartesian coordinates in a way that Z will be vertical at all points. It will be vertical at
how
one
do
or none
you
of the
define Cartesian coordinates in reality? Like, forget about on a spherical model or anything. Just tell me, how do Cartesian coordinates work in reality? Like, how do you use them? I'm telling you, right, X and Y within the Cartesian coordinate system would be on a plane. They would be like, X would be forwards and backwards, and Y would be strafe left and right. The Z coordinate would be an increase in altitude.
Okay.
Yeah? So you would be happy with that?
Yeah, that makes sense.
Right, well, if that is the case, then where do you manufacture a curve from within your spherical model? How do you get that with straight lines to fit on a spherical coordinate system?
Because the straight lines won't be along the surface of the Earth. If you define this coordinate system, for example, at A, then the axes X and Y won't really go. Well, the points B and C won't lie on the XY plane. They will lie slightly below it, approximately 8 inches below it, to be precise.
Below it.
Yes. Both B and C will be slightly below the XY plane if you define the XY plane at A.
Well, it would still be the XY plane, right? Just with a different Z coordinate. Yeah?
Okay, so it won't be. So let's say A lies at Z equal to 0. So then B and C won't lie at Z equal to 0, but at Z equal to -8, let's say, if we take inches as units.
Yeah, but that's just a change in the vertical height over a plane, right?
Over a plane, yes.
Yeah.
But the point is, this doesn't really correspond to altitude on a sphere, because on a sphere the altitude is above a reference, a surface of reference, which is not a plane.
Above a sphere? Well, we can see what a sphere is, right? You can look at a sphere. You can see it's either on the surface of the sphere or not on the surface of a sphere, right?
Okay.
So when something isn't on the surface of a sphere, right, then there's no need to relate it to that surface of that sphere, is there?
Well, it depends.
What do you mean it depends?
It depends what your purpose is. Purpose is to describe stuff on the surface of the Earth, then it's kind of useful to kind of relate stuff to the surface of the sphere.
Surface of the sphere? Where do you hear that? You hear like above an altitude would be, obviously, well, elevation is a vertical difference in between the sea level, which would count as a 0 datum, right?
Yep.
And then elevation is classed as a vertical height above that datum.
Yep. But elevation wouldn't be.
It's measured vertically, right? So when you see like 100 foot above sea level, right, that means a vertical distance. It is 100 feet above that datum.
Yes.
Right. Okay. Now,
except that doesn't correspond to any Cartesian coordinate because it's on a sphere. It's closer. If you want to use elevation as a coordinate, then you arrive at spherical coordinates.
It's vertical above the datum, right? It's a vertical distance.
Well, yeah, but the vertical is a radial direction on Earth. So basically,
a vertical is a vertical. It's a straight line. It's not a radial anything. It's just a straight line.
Well, the radius is also a straight, segment of a straight line, right?
Yeah, chord's also a straight line. A tangent's a straight line. A straight line's a straight line, right?
Well, yeah.
A curved line isn't a straight line.
Well,
right?
Yeah, hard to disagree.
But vertical is a straight line, right?
Yeah, right.
Okay, now a vertical height above your mean sea level datum, 0. That is perpendicular, right? Because it's a vertical height. You can't measure a vertical height without it being perpendicular to the surface it's underneath, right?
Yeah.
Okay.
Yeah, you can say that.
Now, do you want me to get you a Has somebody been talking to Mr. Sensible? He's can't stop as I'm busy, but Bev, you busted yourself with your wiki image above. I think you need to read what you highlighted yourself. Take care and stay sensible. That's Mr. Sensible. Did you have a read of that? Did you? He's just wrote it in the debate discussion. 8:30. Did you have a read of it? Did you disagree with anything in the water level? Or do you think Mr. Sensible's trying to give you a hint? Do you want to have a look over that? Should we have a look over it? Were we in the middle of making a point about anything then? And I got distracted. Does anybody help me out? I think I was going to go and try and find something for you. But I got distracted. I might come back to it in a minute. We'll go after this.
No, you were talking about elevations being a straight line. Tangent was a straight line. A chord's a straight line. Everything's a straight line. And somebody needs to curve straight lines to get what he's looking for.
Right, perpendicular. We best get it out the way with, because...
Okay, yeah, I've read this part of...
Okay.
Read this text about the water level, and I kind of agree, except...
Can I just go over this, what a perpendicular is, right? Because this is definition 10, book 1, Euclid, elements, the elements. And it says, definition 10, right? When a straight line standing on another straight line makes the adjacent angles equal to one another, each of the angles is called a right angle, and the straight line which stands on the other is called perpendicular to it. So that's basically the definition of what a perpendicular is. Right? And it's when a straight line standing on another straight line.
Okay.
So would you agree with that, right? Because that is the definition that we're going to be using whenever we say perpendicular.
It sounds reasonable.
Brilliant. Well, it sounds brilliant because it is the definition within an axiomatic system.
Yeah,
and
that's
it
okay.
works. And that right angle's very important, right? That relationship between that one straight line and another straight line. And that right angle. Ultra important. Especially within triangles, measuring distances. Okay, so let's go back to his water level. That's it. So what do you think he... what busted... Because he seemed to think it was something that I'd highlighted. I'll read it out, right?
Yeah.
A water level is any device utilising the surface of liquid water to establish a horizontal plane of reference, used to determine the apparent inclination of an object or surface and for matching elevations of locations that are too far apart for a spirit level to span. The simplest water level is a section of clear tubing partially filled with water. Water is easily procured for use and easily discarded after use. The ends are held vertical and the rest of the tubing lies on the ground or floor. The water level at each end of the tube will be at the same elevation whether the two ends are adjacent or far apart. Water levels have been used for many years. The water level is a lower tech than the laser level, but it can be more accurate over long distances and works without a sightline, such as around corners. To avoid error, all of the water should be at the same temperature. Other sources of error include difficulty reading due to meniscus. Yeah, which was the bit you thought Mr. Sensible had spotted.
Yeah, if I was to guess, then I would say that he probably refers to the bit about the water level at each end of the tube will be at the same elevation. whether the two ends are adjacent or far apart. Because
If I had to guess, I would have said the same thing as well.
Well, elevation, like we've just said, is a vertical distance above.
Yep.
Yeah.
But the point is that points with the same elevation form a sphere on Earth and not a plane.
Where did you get that from?
Approximately,
Where does it say that?
Well, basically from
elevation.
Kind of
Is that,
hundreds
are you
of
getting it
years
from
of-
elevation then? Is it that word elevation? Should we go and have a look at? We'll have a quick search for elevation, seeing as
I think Sensible was being a bit cryptic with his message as well.
Yeah.
He's just come in here and he's just dropped this. Can't really stop as I'm busy, but Bev, you have just busted yourself with your wiki image above. I think you need to read what you have highlighted yourself. Take care and stay sensible. Well, he should take some of his own medicine with that one.
I've got that.
And he needs
this
to
one.
start using some logic, if you ask me.
Well, he doesn't do
But-
that, does he? Doesn't do logic.
No, and he's been really cryptic.
It says
he's come
here
in-
the height definition of elevation. I'm guessing the height above the level of the sea. Altitude. Would you agree with that? Is that?
Yep.
The
that
height
sounds
above
okay.
the level of the sea. Now, I'm using Merriam-Webster here. Would you be all right with me looking up the definition of level?
Yeah, sure.
Okay. Now, it says here, definition, level, tool, noun, a device for establishing a horizontal line or plane by means of a bubble in a liquid that shows adjustment to the horizontal by movement to the center of a slightly bowed glass tube. Well, that's horizontal, right? Oh, well, I mean, this one's maybe even better. Number 3 of the noun, horizontal condition, especially the equilibrium of a fluid marked by a horizontal surface of even altitude. Do you like that?
Yeah, up to some precision, of course.
What do you mean? It's a horizontal condition.
Okay. Yeah, I mean, basically many words have definitions that work in some context and are not necessarily fully general.
Horizontal, then. Should we have a look at horizontal?
Sure.
It's a straight line, isn't it?
Yeah.
Yeah, it's
Probably
perpendicular to
line or
vertical,
plane,
isn't it?
yeah. Yeah. Usually, I would guess it's defined like that. Yeah.
Okay, so that would, if equilibrium of a fluid marked by a horizontal surface of even altitude. Water seeks its own level. Is the I'll get it for you.
And that's basically what I said, that it's, well, with some it's good enough for most applications, I would guess.
Sorry.
I mean, can you repeat the this definition of level, because I don't want to misrepresent it.
I'm putting the this is we're talking about water, aren't we? So I've put the I've put the horizontal condition. I'll get another one for you. You want the tool?
Yeah, so basically that's unfortunately kind of an approximation. So yep.
That's an approximation.
Yeah, kind of. I mean, colloquially you'd understand it like that, but if you need precision, then basically surface of a fluid is not exactly horizontal. It is horizontal. It is close enough to horizontal at small distances, but
it doesn't say that.
So that
it doesn't say. Well, at what point of a horizontal would you have it bending?
Sorry?
When a horizontal line gets a bit longer, at what point would you have that angular change to the horizontal?
There's no concrete point. I mean, it's only horizontal at a single point.
At a single point? But it can't be a straight line, right? You've just backtracked. We started it off at the beginning. A horizontal line is a line. It's marked by 2 points at each end of that line. You can't have a point perpendicular to a straight line, because that's not what a perpendicular is. We just agreed that earlier as well.
Yeah, but the line, it can only be said of as being horizontal at a single point, because at any other point it's not horizontal anymore.
It can't be a straight line then. It can't be a horizontal straight line.
No, because a horizontal is a straight line. So the whole straight line is something that we call horizontal, but it's called horizontal at a single point.
Sorry? A horizontal line is only called a horizontal line at a single point. And where would that point be along the horizontal line, that the horizontal line was actually horizontal?
The point at which it is perpendicular to vertical.
But you could, because it's a horizontal line and it's a perpendicular, you can surely make a perpendicular to it at any point.
And that's the problem, because not on a sphere, not if the Earth is a sphere.
Yeah, but a sphere can't be a horizontal line, can it? I mean, that is a bit of a problem, that you can't seem to make a horizontal line into a sphere, because it's a straight line.
But nobody's trying. The horizontal line is a line, but it's only horizontal at a single point, because the vertical is perpendicular to it only at a single point.
Draw me a straight line, right, that you can only do a perpendicular at one point of it, please. Just show me it. Like geometrically, just draw me a straight line and show me the point on that straight line where you can draw a perpendicular. Do you know how to do a perpendicular in geometry?
But perpendicular to a vertical, so
well, perpendicular to a straight line. No, a straight line is what is needed in order to make a perpendicular. We did just go through it before. We didn't mention vertical or horizontal. We went over the definition of a perpendicular, and it requires two straight lines.
And the straight lines here are vertical and horizontal. But the vertical at a concrete point, because the vertical at a different point will not be perpendicular to the this horizontal line anymore.
Who says that? Did
Yeah,
you just made that up right then?
Not really. That's basically what you expect on a sphere.
Who told you that? Who is your source of knowledge that has told you that whatever you just said then? Because I think you may have made it up on the spot. I don't think I've ever heard anybody repeat it say like that before.
Well, so that's basically what you would get if
it's not basically what you would get at all, and it's not basic geometry or anything like that. No, you've took a straight line, you've turned it into a point, which is a nothing, in case you didn't know.
No, I didn't
and
turn anything into a point.
Imagined it bends around a circle of an imagined size.
I have done no such thing.
Yeah. That's exactly what you did. You turned a straight line into a singular point, and then bent that point.
No. I said that the line has some property only at a single point. The line is still a line, but it has some property only at a single point. So there is a difference between there is a difference between having a property at a point and being a point.
What's your definition of a point, and where do you get that definition from?
As far as I can remember, the point is said to be what you call a primitive notion or something like that.
That of which has no parts is the definition from Euclidean elements, because that's the geometry we're using, right? That's where the definitions of these things within geometry come from. Definitions of straight lines and angles and circles and curves, all of that sort of stuff. The definitions are wrote within Euclidean elements. They're wrote into the. In fact, there's a whole section about them. It's called definitions. It comes before the propositions with the proofs of the geometry. It's a fascinating book, which I presume that you haven't really looked at or looked for, because you're using what I term as fight the flat Earth geometry. Now, it's not actually, you imagine it's Euclidean geometry, but because you are, let's say, geometrically illiterate, that you just imagine it has to be whatever you want it to be.
Not really.
Well, you have no geometrical proof of this perpendicular that isn't perpendicular to other lines that it is meant to be perpendicular to.
Wait, let me finish the drawing. I will upload the drawing shortly.
Do you have an idea of a straight line as well? Straight lines don't curve, do they?
Yeah, basically, by definition, I would say.
What a straight line is a straight line.
Maybe not by definition, because a straight line, I think, is also a primitive notion. But
sorry,
yeah,
say
but
that again.
Straight lines don't really curve.
It's a primitive notion.
Okay, maybe I'm confusing words. I'm not sure what it's called in English. Sorry. Let me find the proper word for that.
First principles.
First principle, maybe. Yeah, that might be the correct. Let me just check the translation.
It is a straight line.
Primitive notion. Yep. Actually, it's called the primitive notion. So basically, it's quoting Wiki right now. In mathematics, logic, philosophy, and formal system, a primitive notion is a concept that is not defined in terms of previously defined concepts. Okay. So basically, it's something so basic that you can't really define it, because if you were to define all notions via something else, then you would have an infinite ladder of notions that need to be defined by something more basic, right?
Right.
So you need to choose some primitive notions that you don't define, but you assume that you just know what you're talking about, or something like that.
But in Euclidean geometry, a straight line is defined. It's not a concept or anything like what you've just said there. I mean, built upon first principles, but Euclidean geometry is defined. It defines itself. This is an axiomatic system. It takes, like this is like nothing else. The reasons for them doing it, I don't know. I can only imagine they must have had a load of people that were arguing stuff that they were just trying to obfuscate constantly about things. So some dude just sat down and went, right, this is how we're going to get our proofs, right? So a straight line within Euclid is defined as a straight line is that which lies evenly between its extreme points. And just before that, it said the extremities of a line are points. So that means that a line ends with a point at each end, and a straight line is defined that which lies evenly between the 2 points.
Okay.
So that isn't first principles. I mean, it's not even a common notion. The common notions within my book are built into the axioms.
Okay, but I would like to go back to the thing about verticals and horizontals. So I drew a simple image. I uploaded it in debate discussion. If you can take a look.
Yeah.
Yeah. So basically, I drew a circle that is supposed to represent the surface of a spherical Earth. So if the Earth is a sphere, then this would look like that.
That's a circle.
And you have
I'll give you that. We'll pretend that's a circle. Seeing as we're doing geometry, right?
It's not a perfect circle, obviously, but yeah. But it's close enough. Let's say that it's a circle.
Yeah.
And
I'll give you that.
V1 and V2 are supposed to be verticals at 2 different points. So you have the point
but they
of
are
intersection.
just extensions of a radius, right? They're radial
Well, yeah.
lines that you extend out beyond the circumference of the
Yeah,
circle.
but that's what a person standing at the at the points of intersection of those verticals.
In your
on the-
imagination that you're just doing right now.
Okay, let's say that in my imagination. But basically, if the Earth was a sphere, those V1 and V2 would be the lines that people standing in the respective points on the surface of the Earth would call vertical.
Yeah, they're what you imagine as a vertical, yes.
And then H1 and H2 would be what they would call horizontal. And the horizontal H1, which is perpendicular to vertical V1, is not perpendicular to
next
vertical
time,
V2.
right angles are like if you put a square edge. That's how you denote a right angle.
Yeah, I was just drawing this manually by hand in a program, so it's probably not precise, but
yeah.
it's
Well,
only
you've
supposed to
what
illustrate
you've
an
done
idea
there
and
is
not
you've
perfect.
just marked an angle. You know.
Well, yeah, but
if you'd have done it like a right angle, like a square edge, it would have denoted a right angle, and then we would have known that them two lines would have been perpendicular, because the right angle, as it's defined as two straight lines and a.
Oh, I know what you mean. Yep.
Yeah.
So, yeah, because we usually mark right angles by an arc with a dot inside. But
Oh,
yeah,
is that what you do? You don't, not with a square edge, a right angle.
Yeah, I know this one, but yeah, I was used to doing that at school, so I guess that's just a local thing, maybe.
Wow. Okay.
Where are you from? Sorry.
From Poland.
You're Polish. Huh?
Yeah.
Uh-huh. How come geometry is different in Poland?
No, geometry is the same, I believe, but yeah.
I thought
But just what you use to denote angles within geometry.
Yeah,
is
maybe
different.
maybe annotation is a bit different. Yeah, I don't know why.
Yeah. Okay. So,
Which
but
one?
yeah, I see that one with the dot. What you mean
Yeah.
is a right angle there. So
Yes.
they're perpendicular lines to the extension of the radius. Yeah. Okay. So, yeah. So one of them H2. When that intersects V1, because that is a horizontal. When that horizontal intersects the vertical, that V1, horizontal 2 intersects vertical 1. That is a horizontal that's intersecting a vertical, but they are not perpendicular, are they?
Yeah, because it's not horizontal at the point at which V1 is vertical. I should probably also denote the points.
I'm not so sure that's how it works. You know, in reality.
I believe that's how it works in reality.
But you've never worked with anything that would give you that impression, right? This is just what you're imagining.
Not only that, but well, maybe I haven't measured this directly, but many different facts point to it being like that, I would say. Wait.
Well, I can understand that. Well, I mean, that idea of the geometry that you're imagining there, right, is sort of why I think we're doing our test, right? Because when we say that a horizontal level is horizontal, and it is a tool to establish a horizontal, you guys don't seem to imagine the same sort of thing. I think personally, because you have a point that horizontal is, and then that's next to another point that's horizontal, and you've got a really bad misunderstanding of what perpendiculars are and all of that, that you imagine that horizontal line is actually a bent line that goes in a circle. It's like a circumference of a circle.
No. Horizontal line is a line. It's straight. Except it's only horizontal at a single point. Okay, so
that's not a line. That definition of a line is not a single point. That's the definition of a point. A line cannot be a point. That's like an oxymoron.
Yep. But that's what I was saying. A property is different from being, well, a having a property at a point is different from being a point. The line is a line, but it only has a property of being horizontal at a single point.
Right, so what is horizontal to you then?
A property of a line, which can only be true at a single point.
Right, and where would you get the definition
Hang
for
on.
this?
He's just said probably at the end of that sentence.
Yeah,
why a probably?
Why maybe I shouldn't have said that.
No, exactly. Why are you working in probabilities? Geometry isn't about probabilities.
Geometry not, but all of science kind of.
No, we're not talking about science, are we? We're talking about geometric proofs. And you've put a probably at the end of your sentence, which gives the impression that you don't know what you're actually talking about.
No.
Yes,
the problem is that... Well, okay, maybe it gave this impression, so that was my mistake. But the problem is that the notion of vertical or horizontal, those are not geometrical notions. The whole notion of verticality is something that is connected to the direction of up-down, which is defined by gravity, which is not part of geometry.
Now you're using gravity to define up and down.
Okay, which is related to direction objects are falling, if you prefer. Whether we call it gravity or whatever else, it doesn't really matter.
Man,
but the point is that
you are so far out of your depth.
The whole point of it is that vertical is a notion that is something about the physical world, and it's not a purely abstract notion that is just in pure geometry. And
Right,
by
so the
extension,
vertical is a straight line, though, right?
Yeah, usually
Okay,
it's
now
defined
a
like that.
perpendicular is the relationship of a straight line.
At the most basic level, yes, but you can generalize it
What do
to
you mean
arbitrary
at the
curves.
most basic level? Yes, it's within an axiomatic system of the geometry that you actually use.
Yeah, but the point is that if...
But you know better.
No. The point is that mathematicians often... Well, maybe I started from the wrong side. So notions often were being created in simplest possible case, but then mathematicians found a way of cleverly generalizing that, so the same notion is applicable to basically more cases, and that's also the case with perpendicularity.
Okay, so go on then. Give us the mathematician that said that Euclid's wasn't quite right, and we're just gonna tweak this. What a perpendicular actually means.
It's not that Euclid
because
wasn't
the
right.
notion of it wasn't right. Well, what the hell did you just say?
It's not that he wasn't right. I didn't say that Euclid wasn't right. It's that you can extend it. You can modify the definition of perpendicularity in, well, maybe not modify, but extend it in a way that you can use the word perpendicular, referring not only to straight lines but also to arbitrary curves.
Do you know what word salad is?
Can I just check there, right? You said you can do whatever you decide, right? Because mathematicians decided, right? Do you imagine that you are one of these mathematicians? And is the reason you are dicking about with Euclidean geometry the reason that you have a model that doesn't seem to fit with any of these straight line definitions within Euclidean geometry?
I wouldn't call myself a mathematician, but I am a physicist by education.
Okay, but you just dicked about with a straight line then?
How so?
Well, a perpendicular, as we just described before, is a relationship of a straight line to another. Now, because of the fact it's called perpendicular, and it's a relationship of one straight line to another, you don't need to say which line is the perpendicular. They both are. But you, of being the genius that you are, decided you were going to turn one of them into a point. So that is a point on a straight line, which is a perpendicular. But which perpendicular? No. Don't know. They both must be points. Hey presto, you've lost both of your fucking lines.
I've never said that the point is perpendicular to a line.
You said the horizontal is perpendicular to a vertical at the point that it is on the vertical. So it's only horizontal as long as it's on the same line as the vertical.
No.
Yes. You said it many times. You can't have a horizontal line being a line.
That's not what I was saying.
Okay.
I was saying that the property of being horizontal is only makes sense at a point, but it applies to the line.
Sorry,
as a
it
whole.
only makes sense.
Yes.
What, a horizontal, the property of a horizontal line only makes sense to you because you have a model that you're trying to imagine around geometry. It only makes sense when it's at the point. Where have you ever seen that? At any point?
I'm not sure what you're trying to say.
Well, I'm not so sure what you're trying to say. You're trying to get rid of a horizontal.
No. Not trying to get rid of anything.
Horizontal is or is not perpendicular to vertical, please.
Well, yes, it is. But the whole property of being horizontal is defined at a point.
Definition of horizontal. 1A. Of or relating to the apparent junction of earth and sky situated near the horizon. Doesn't really relate to us, that, right? B. Parallel to, in the plane of, or operating in a plane parallel to the horizon or to a baseline, level. A horizontal distance, a horizontal engine. Now, I would say that's pretty much thing. So we've got parallel to. Can you have parallel to a point? Don't think so. No, such fucking thing, right? What about in the plane of? Well, a plane is a two-dimensional surface that extends indefinitely far in every direction. Operating in a plane parallel to the horizon. Well, that's a plane, two-dimensional surface, and parallel to the horizon. Well, you can't have that as a point because the horizon definitely isn't a point, is it? Or to a baseline. Right now, a baseline isn't a point. It didn't say point in that. And then it says level to add in as well. So horizontal, level, plane, parallel to the horizon. That's horizontal, right? Doesn't mention anything about a point or a concept of a notion of a horizontal.
No, it's not. But
it actually gave us real definitions.
Because if you take a look at this, if you see parallel to the horizon, right? But I'm pretty sure that you could agree that observers standing in different points on the Earth have different horizons, right?
Parallel to, though, right? Parallel to the horizon. So when when you look in, imagine you stood on an island, right? And you've got a 360-degree view all the way around you, right? Would parallel to that be parallel all the way around you? Would it be parallel to the same thing? And that's a plane parallel to it.
Yeah, that would be a plane parallel to a plane of the horizon, because the horizon also lies in a plane.
Yeah, but it would be called a horizontal plane then, right?
Yeah, that makes sense. But then if you have a different observer on a different island, then if the Earth is spherical, then the plane of their horizon is different from the plane of your horizon.
Did you throw an F in then?
Yeah, for the sake of argument, because I know that you don't agree with that.
Logical. Okay, finish it off then. If.
Yep.
Go
so
on.
Basically, if the Earth is a sphere.
Yeah. P.
For the sake of argument.
P.
When you have two different observers on two different points on the Earth, then a horizon, the plane of the horizon of one of them is different from the plane of the horizon of the other one.
Can you prove that? Is that your cue?
Well, yeah, I could probably do that, but
Are these different heights of people, right?
It doesn't really matter.
Well, would it be a different plane then, right? You could have two different planes that are parallel to the horizon, can't you?
You could.
And they would be parallel to each other, wouldn't they?
No, the point is the
you could. You could have two planes at a different height that are parallel to the horizon, and they would also be parallel to each other.
Yes.
Yeah.
But if you have two observers at different points on the Earth, not just at different altitudes above the same point, but at different points altogether, then their horizons, the planes of their horizons, wouldn't be parallel to each other. It would be like H1 and H2 on my drawing, except the H1 and H2 would be the planes parallel.
Would the horizontal be in a different place?
Yeah.
Right, so let's imagine, right, I'm looking at the horizon, and we've got, you can be in front, right? You walk off in front of me to like a mile in that direction. I can see you, and DP walks off to my right, and somebody else walks off to the left. Over at Emma can walk off to the left, right? Now, I'm looking at the horizon, and you're looking at the horizon. Everybody's looking at the horizon, right? Would it be on a different angle?
Well, yeah.
Would it? Because I'd be looking over the top of your head, right? Well, that would be horizontal, wouldn't it? That horizontal wouldn't change, would it? And then if I turned and looked at DP, and he's walking off to the right, now he'd be looking out at that horizon, and I'd be looking over the top of his head, or just past him. But that would still be on the same horizontal plane, wouldn't it?
Well, if you are looking in different directions, then yeah, it is on a single horizontal plane. But if, for example, DP was looking in his horizontal plane, then that would be a different plane.
He would just be walking off into the horizon that I'm looking at to my right. He'd be looking and walking in that direction. That would be, it would stay the same horizontal, wouldn't it?
Well, no, because as the farther he is from you, the more
to left to right, though, right? The left to right wouldn't drop.
Yep.
Left to right, would it?
Well, his vertical would be more and more tilted relative to your vertical.
Yeah, but that's only your imaginary tilt, like away, but like forwards and backwards, right? It's not the horizontal would stay the same, wouldn't it?
No, because the horizontal. No.
Yeah, because the parallel. It says parallel to it, right?
Yep.
Yeah.
But basically, the plane. Well, if you take horizontal as the whole plane and not just a single direction, then those wouldn't be parallel, right? Because he has a different vertical.
I'm just talking about in reality, right? If DP, everyone was holding a spirit level as they're walking away. Right, and you're all walking away from me, and then when I turn towards you, I've got a spirit level, and you're walking away with a spirit level. It would be on the same horizontal plane, wouldn't it?
No.
No.
No. Slightly different and more different the farther we would be from each other.
On which sort of tilt, though, on the horizontal?
But maybe you were talking about something else. Oh boy. How are we holding the spirit levels? Are we holding it along the direction
I'm holding
we are walking,
it sort of perpendicular to the guy that's walking away from me. So I'm turning, but you're just walking. You've got it, and you're holding it up towards the horizon, and you're walking towards the horizon, right?
Okay,
so it's staying on the same horizontal as your horizon, as you're walking.
Yes. So in this case, yes.
Okay. Now, I'm a mile behind you, and I hold my spirit level up, and that's level with the horizon as well. and then you're in front of me doing exactly the same thing. Would that not be on the same horizontal?
If we are talking only about this direction perpendicular to the line connecting all of us, then yes. But the point is that if we rotated the spirit levels and we were interested in the direction parallel to...
you said it's only at that point, though.
What do you mean?
You said it's only at the point that you're at. And like we've just showed now that the horizontal is horizontal at 2 different points. And then imagine then I could turn and face DP and he's doing the same.
Okay.
And we would have the same.
We're now confusing horizontal lines with horizontal planes and 2-dimensional situations with 3-dimensional situations.
We can hold a plumb bob above our heads when we're doing the a horizontal, right? Because I mean that's what you're doing when you're holding a spirit level, right?
Okay.
Yeah. So you're saying that it's only horizontal in one particular direction when you're facing one particular way?
No, to be honest, I don't want to answer because I'm not sure what we're talking about anymore.
Okay, well, yeah. Well, I'm just trying to imagine now, right? Because you're imagining the vertical or whatever. Now, I was in the centre and all of you lot worked away, but then would I be higher than you on your model, like when I'm looking? But when you're looking back to me, you would be then above me, and that's why you're imagining there's a difference in the horizontal planes.
Kind of, yeah, we could say that, I guess.
Okay, so...
Anyway, sorry, I have to apologize, but I'll have to leave.
Oh, okay.
Okay.
Well,
yeah.
Nice. Just when it's getting
I'm already...
interesting, you have to leave.
Yeah, sorry, but yeah,
it's amazing. Everybody's the same, you know. We get to a certain point, and then nobody wants to talk anymore.
Okay.
And you are exactly the same.
Do you want we can go back to the topic at another?
And you have to go.
It's all of you guys never get to hear the end of the story, do you?
Yeah.
No, they don't want to hear the end of the story, Bev. They're
Unfortunately,
scared
there was
of something. There is something in here that is tying them so far in knots that they have to run away from it.
If you want to believe that.
No. This is proving to be evident because we get to a certain point in the conversation and suddenly everybody has to go.
The problem is I'm already over time, actually.
You have just reached that point. And it is hilarious.
Please come back.
Absolutely hilarious.
We could try and pick it up from this one next time. Horizontal planes.
Sure, why not? We can.
And how they're different to horizontal lines. What's the difference between?
If you think about that, there wasn't really any point during our conversation where it would be a good time to leave so that you wouldn't be able to say what you just said. So, and actually, I only had finite time to stay and talk. But yeah, I have nothing against picking up where we left off at some other time.
Sweet, thank you.
Okay, so thanks for the conversation, and yeah, see you another time probably.
See you later.
See you later.
Yeah, thanks.
Nice.
The same thing happened to me and Godscalper last night when we were talking about it. They just leave.
You get to a certain point and they have to go.
They have to go. They've got no choice.
You found the crossroads. I mean, you found that point where the obfuscation they come up with is just ludicrous, and I think they hear it in their own voice. Have to.
Yeah. Do you think it was that I've never really got that far into it before? I'm still recording, by the way.
Yeah.
So, I never really got that far into it where we ended up going and I don't know. He got to that bit where we're looking at the horizon and the horizontal and it's a line. Right? And then if you can't they can't have, right? Here's the problem. The perpendicular is dictated within geometry, but everybody knows what that means. It's a right angle. A right angle's pretty definite. Now, on their model, if you drop a vertical, it can't be horizontal. It can't be perpendicular to a horizontal. More than one horizontal. It's ridiculous. But a horizontal, by the fact that a vertical is a line and it turns through 360 degrees, it turns it into a plane. So you can't get away from that horizontal plane, which is a line. So if you just imagine turning round in a circle, looking at a horizon and holding a plumb bob, that plumb bob's perpendicular to the horizon. The horizon's every line that is parallel to the horizon. So therefore, every time you hold a plumb bob and you can turn it round 360 degrees, there's a horizontal perpendicular to it every time you're holding it. But they can't have that. It doesn't work on their model.
Right.
That becomes a tangent plane for them, doesn't it?
Yeah. Which is always
ridiculous.
Constantly moving. I never got round to the wearing a skirt. Standing on a ball wearing a horizontal skirt with a big pointy vertical fucking hat with Zenith wrote on the top of it.
Oh dear.
Balancing on a ball. Always being on the top of it. What's wrong? The big, instead of holding one of them balance sticks, just a big skirt.
You never even got to the canal. You never even got.
We did the did the Ballers Canal
briefly.
Yeah, but he was fine with that. Yeah, 24 inches.
And he contradicted what who was it said that it's separate surfaces, that each of the vials in the water level contains separate surfaces.
Yeah, different horizontals on each of the tops of the vials.
So even amongst themselves, they haven't got their story straight.
Yeah, I like when they draw it. Just draw a circle and put some radius on it. Call them vertical. Fuck it. Who cares?
The few conversations I've had with people, they're just not going to relinquish that you can keep that straight line going over the mile. They're going to say you have to drop a new plumb bob, and that plumb bob at each point you reference, that's where the trick comes in. That's the conversation we had last night anyway, was where that first datum point, you can't transfer that to your next reading. You have to drop a new plumb line. And that's where
every point.
That's
every
rubbish.
Point.
Yeah.
Because then, how can they have anything that's ever level of distance?
Bendy's on all right.
That's what I'm saying. That's where the argument we had last night was that you have to drop a new plumb line because they can't relinquish that you can draw a straight line based off that first reference point, because then they have to relinquish that you're going to show either a hump in the middle or a dip at the end.
Well, you know,
that's why they deny our test.
Even when they put drainage in, when they're building a housing estate, and they want to put the flow on drainage, you have to form a horizontal line, a plane, and then you drop the flow of the drainage from that horizontal plane formed.
Yeah, but you just don't understand. This is what Larry Scott told an audience yesterday. He stopped at one of his local businesses just on a hunch, right? Took out his auto level, shot it from one end to the other, which was about a half a mile, big long building, and it had a 2-inch drop in elevation from one end to the other.
Wow.
So which means
Did he
that
go to the other
slab-
end? Do a reciprocal?
No.
Ah.
Yeah. It's one shot, point A to point B, and lo and behold, had a 2-inch, just what you would expect on a curved surface, the size that we live in. He's saying the
was a slope.
slab. No, he is saying the slab is following the curvature of the Earth.
Oh, well, he should be able to go to the other end
Right.
and do the 2-inch again. But I mean, like we keep saying this to DP says it a lot, that you're only measuring a point to a point. That's a tilt. That's the best you could get.
That's what
Like-
I said. You should go to the middle, right? Shoot the middle, and then shoot both ends, and both ends should drop if you're
Yeah.
on a curved surface,
Yeah.
a sphere. No, that's not the test. That's not the best way to do it. And then George backed him up. Oh no, you take one shot, point A to point B. That's the best way to do it.
Half a mile.
Isn't that even obfuscating, because he's measuring concrete level and they're trying to measure water level?
Yeah.
That's still obfuscation.
That was my point. Wouldn't the water? Okay, so say you built a trough, on each end of that, on that slab, or poured water, or had a water leak in the middle of that slab. Would it run off to each end? Oh, you just don't understand. That's why water pools, and when concrete's not level. And I'm like, you're telling a concrete finisher, I've built buildings like that. Why water pools in the middle and all, I'm like, but the audience eats it up. That's what they want to hear. Larry Scott, the surveyor, right? Their expert is telling them, this is how you do it. You take a shot from a half a mile away. You get a 2-inch, whatever he calls it. I don't even know what he called it. And that's curvature of the Earth. 100%. That was yesterday.
Larry over at Jose's.
At Jose's, yeah.
Well, I thought they're not allowed to talk about level, or is it just me that's not allowed to go over there and talk about this to their
Well, they're
surveyors?
surely allowed to talk about level and you, because they talked about you, me.
Oh, right. Well, I'll have to have a word with Jose when he comes round here. Because it's a bit of a running joke with him that I'm not allowed to talk about, I guess, anything that destroys their model.
Larry had a video of him, a picture of him actually doing that observation of that test, of his data,
Wow.
showing that curved slab.
It's okay to test the deviation of concrete, but not the deviation of water. So
Right.
It's probably
Right.
Well, yeah, I mean, we've been looking for these surveyors to come and have a talk to us about this test, and they won't. So I find it a bit strange that they are in there talking about doing things like that and not able to talk about the test that we have. I mean, you heard that guy there just have such a problem with the geometry based around it, and these surveyors should work with that, surely. We might have to go over and ask Jose, see what's going on, see whether he wants to set up a conversation.
Is George Nutsack back in there?
Yeah.
Yeah, George was there yesterday telling me how he brought my name up several times, and Bev's again, about how wrong we are.
I thought Ranty's was the only server where he feels safe, and that guy's got such mental
That was
problems
when he
somewhere.
got kicked out of Jose's, I think.
Oh, right.
The problem is with George, right, is that he contradicts everybody and he jumps on top of everybody else because he imagines he's the top bod. Now, if there's no, let's call them flat earthers, for want of a better word, right, to challenge him, they're allowed to just say whatever they want and they'll get away with it because, like Rakir just said, the audience eat it up. Like that guy, no reason for him saying what he said other than his model dictated it. And his model dictated what he imagines happens in reality, which working people know that isn't what happens.
You tear them up when you start talking about it's in their imagination. That just goes in one ear and out the other. It's not human. It's in your imagination, right?
Wow.
Imagine if I went in there and showed them a concrete slab that was horizontal, right? I did a shot from A to B and showed them how it was perfectly horizontal. And that's proof of a flat Earth, right? Which would be ludicrous, right? They would eat me alive. But when Larry Scott was showing that slab showed a drop or Earth curve, it was falling Earth curve, perfectly fine, no problem.
Yeah. That would be fucking ridiculous. Can you imagine you doing that and going, yeah, 2 inches, yeah, that's right, isn't it? And they go, no, we wanted it level. Yeah. Yeah. 2 inches, look at it. Spot on that.
Right. I'm level following the center of the Earth. Pay me, right?
Yeah.
Where in the contract did you mean, level?
Yeah, you didn't stipulate which level. I've been on Discord talking to George and Larry.
Yeah, expert surveyors, right? And level is from the center of the Earth, which this slab is perfectly level to the center of the Earth, right? Because it's 2 inches over a half mile.
Only from one end, though. Didn't bother checking it from all the corners or anything like that. Fuck that.
Or from the middle out. Yeah. That's too short of a distance, right? My machine is too calibrated, to pick up the short, quarter mile from the middle. It wouldn't do that. That's too, you have to go over long distance, point A to point B.
You have to go over a distance you can't actually see 2 inches to measure
and at
it.
a certain angle. And at a certain angle, too, to the building. Make sure you do that. Yeah, buddy. They ate it up. It was like a 30-minute presentation. I think it was 30. I mean, let me back up on that. He was talking a long time. That part might have been, maybe just showing his picture and blah, blah, blah. But it stuck in my mind because I was like, these people are really losing it. Hey.
Yeah.
Yep, sure did. Now, the slab he was shooting the outside of the building, of course, and they had like lighting or different color paint that was meeting the slab, and that's what was judging. Right, that little yeah, where the edging of the concrete met whatever jointed or whatever the groove was on the outside that kept the water from going, whatever it was. That's what he was using as his gauge. Yeah, buddy. I thought I had taken a picture. I need to go back and look and take a picture of his shot. Because he took a picture through his cross, through his scope.
Do you know what word salad is?